Hey, what's up, ladies and gentlemen, boys and girls? I hope you all are doing well. So, lesson today. This is what we're going to be looking at: Introduction to Rules of Differentiation, Grade 12 Calculus. This is one of the most, popular topics in Grade 12. Calculus, right? And I know, this video is being produced, just before December. People are not in the mood to learn and all that. But what I'm saying is, just party when you're tired, then get down to it. Especially the grade 11s; those are passed. So let's get right into it, right? Introduction to differentiation. So the rules of differentiation. So guys, I need you to pay attention now. So the first rule of differentiation, right? The first rule of differentiation that I want you guys to, this is what we call power rule, okay? Power rule, right? It's very important that you you know the name of the main rule that we use to differentiate powers, right? So yes, and now let's suppose that we've got this power here, a, right, x to the exponent n. Okay, so let's give it, let's say that power there is just y, right? In other words, this is a function of y. Okay, so now we want to differentiate y, and someone might ask, okay, when we differentiate, what are we doing to the function? Because differentiation is basically when you are finding the derivative of a function, right? But the question is, what is the derivative itself, right? Okay, what is the derivative? What is the derivative? And the answer is quite simple. And the derivative has got quite a number of notations. Some people, they use dy over dx to refer to the derivatives. Some people, they use y prime. Some people, they use dx. There's quite a lot of notations that are used to refer to what we call the derivative. But what is it? Okay, now a quick example is when you've got a parabola like this, okay, and then you've got some tangents, okay, you've got some tangents, right, for the parabola, some tangents. So obviously tangents, we're just referring to the lines that are touching the graph once, okay. So now these tangents, okay, these tangents, they've got gradients. Do you understand? I want you to pay attention very carefully right now. These tangents, they've got gradients, okay. So now the gradient of a tangent, right, the gradient of the tangent is what we call the derivative. In other words, if the gradient of this line is m1, the gradient of that line is m2, the gradient of that line over there is m3, and then m4. Obviously, there's a particular x value there, right? There's a particular x value there. So at that x value, we've got m3. At that x value there, we've got m2. We've got m4, so on and so forth. So the gradient of the tangent, okay, right? The gradient of the tangent is basically our derivative. And if we want to find the expression which represents the gradient of the tangent, right, to our graph, in this case, it's the parabola, right, which is a frown, then we need to find the first derivative or the derivative, okay? So now how do we find the derivative? So to sum it up, the derivative is the gradient of the tangent to our graph. They'll always ask you to find what is the gradient of the tangent? You must know that it is your derivative. So whatever graph that they're asking you to find its gradient, it's whatever tangent that they're asking you to find its gradient, and you know that, okay, this tangent, there's a particular function that it's tangent to, then you're going to use that function to derive, and then you'll have the expression for the gradient of the tangent. Do you get what I'm saying? So whenever you're trying to find that gradient of that tangent, first think about, okay, which function is this tangent, right, tangent to? Do you get what I'm saying? In other words, which function is that line touching once? Okay, because whenever we say a line is a tangent, we simply saying it touches a particular function once. So now the question is, which function is it touching once? And do we know the equation of that function? And if the answer is yes, that means we can then find the derivative of that function, and then that derivative will then be our gradient, right? Obviously it will be in terms of x. So we'll be told that, okay, the x value is this, then we'll be able to find the gradient. But let's not talk too much on that, because really the focus of today is to figure out what is how to use the power rule. Remember what I said, this is the power rule. If you didn't pick up anything that I said, make sure that you understand what I'm about to teach right now. The power rule. This is the most important rule in calculus. Okay, power rule. So y is equal to ax to the exponent n. So now we haven't done anything to the function. Remember, this is given, meaning that we have not done any differentiation. Now, to find dy over dx, or y prime, or dx, right? This is what we're going to do. We're going to say, okay, dy over dx, which is the derivative, is given by, we're going to take this n over here. That is the first thing that we're going to do. We're going to say, okay, n times the a, right? And then x. Once we're done with that, then we go to the n and subtract 1. You understand? So the first thing you do, you take the n, you multiply with the a, and then once you're done with that, you go to the n, you subtract what? 1. It's just a simple rule of differentiation, right? But obviously with this is the actual power rule. This is the actual power rule, right? Because it's a rule that we apply. So now look, before you apply the power rule, you need to make sure that your function is in standard form, ax to the n. Do you understand? It needs to be in standard form. Otherwise, you're not going to be able to simplify. Okay? So I'm going to give a quick example. All right. So let's suppose that we're given y is equal to x to the exponent 3. Okay? And we want to use power rule to find the derivative of this. So we're going to say, okay, y prime, right? You know that the coefficient of x cubed, right? The number that's here, that's 1. So basically we're going to say 3 times 1, and then x to the exponent 3 minus 1. Okay? And that becomes what? That becomes 3x squared. Okay? Now it's very important to understand what this represents. Okay? This is the gradient of the tangent to the function x cubed at x. Now sometimes we'll be told that, okay, x is equal to 2. Then you know, okay, our gradient is going to be 3 2 squared, which becomes what? 12. So that's the gradient of our tangent at x equals to 2. So x could be any value, right? So that means at that particular x value, the gradient of our tangent is 12. Do you understand? So now look, let's look at a slightly different problem. So let's say now, okay, y is now the cube root of x. Now you can see that this is not in the form of ax, right? Ax to the exponent n, right? But we can fix that, okay? We can fix that. So meaning that what we need to do is we need to rewrite it a little bit differently. So we're going to say, okay, this is the same as x to the exponent 1 over 3. Okay? So now you can see that, okay, a is 1 and n is equal to what? 1 over 3. So a cannot be equal to 0, but a can be any number. Also, n is an element of real numbers. N can be any number. Okay? N can literally be any number. But a cannot be 0, because once a is 0, everything falls off. Okay? So if you've got this now, that means that, okay, to differentiate, we know that the coefficient of this whole thing is 1. So 1 over 3 times that coefficient, which is 1, and then x takes on 1 over 3. Then we need to subtract 1 from the 1 over 3. So this becomes 1 over 3 x to the exponent minus 2 over 3. Sometimes they say, okay, write your answer with positive exponents. Okay, meaning that you want to say, okay, 1 over 3 times 1 over x, right, to the exponent 2 over 3. Okay, so let's do one more problem and then that'll do it. So now let's suppose that we've got this problem here. Let's suppose that y is equal to minus 2 over let's say 3 root x, right? And obviously this is not in the form of ax to the n. Do you understand? So we need to work around that. So this will then become minus 2 times 1 over x to the exponent 1 over 3. Yes, and this is equal to what? Minus 2 times x to the exponent minus 1 over 3. Right, and then now we can go right ahead and find the derivative, because we know that a is minus 2 and n is minus 1 over 3. Okay, so therefore y prime, or dy over dx, is then going to be equal to what? Is then going to be equal to so the a and the n, we multiply them together, so we've got minus 1 over 3 times minus 2 x to the exponent negative 1 over 3 and then minus 1. Okay, so then this becomes what? 2 over 3 x to the exponent minus what? Minus 4 over 3. Right, and obviously if they ask you to write down your answer, leave your answer with positive exponents, you'd say okay, 2 over 3 times 1 over x to the 4 over 3. Sometimes they don't want these type of exponents. They want you to leave it in simplest sad form. In other words, now the 1 over 3 becomes a root, so 2 over 3 times 1 over what? All right, 1 over the third root of x to the 4. All right, and now we know that this represents the gradient of the tangent. So they might say, okay, fine, now find the gradient of the tangent at x is equal to let's say 2, right? At x equals to 2. Then you'd say, okay, m is given by what? By y prime, which is equal to 2 over 3 times 1 over the third root of x to the 4, and x is 2 to the 4. And then you punch everything to your calculator and you find your gradient. So that's it, ladies and gentlemen, and I hope you enjoyed the video. Don't forget to like, subscribe, and share with friends and family. Right, let's kill this math thing. Let's go. Shout out.